Hello, welcome to my presentation that looks to share my two-year project on threshold concepts, the sequencing of a curriculum, assessment, and the impact that that's had with my Year 10 chemistry course. Although this is focused on what seems a very narrow field of chemistry, there are many aspects that can be taken from this project that could be applied to all subject areas. And I really recommend looking into your own threshold concepts within your subjects. It's tricky to start with, but it's very interesting. Let me start by introducing myself. I'm very conscious this is a virtual experience, a new one for us all, but actually it's great because we can access all of the presentations when it's convenient for us, but actually it may feel a little less personal of an experience. So I won't go through my professional blurb because that's been shared by Research Ed already. But two other big passions of mine would be my camper van, which I like to travel, not so much at the moment with everything that's going on around Europe, but this is Puff, and also my love of hedgehogs. This is Spike from my garden. This presentation seeks to do three things: to introduce those of you that aren't familiar with it to the CNS Professional Inquiry, which has helped me lead all of this project. To give a brief introduction to the idea of threshold concepts, and also to share with you my threshold concept research project from background all the way through to the impact it's had and what I would like to do to move forward. So the CNS Professional Inquiry is something that we've done for the last 4 years. CNS require all student-facing staff, including LSAs, to carry out their own professional inquiry into an area that either the school or their faculty, their department have prioritised for that year. It forms part of our appraisal, but more importantly, it encourages staff to engage in a professional research, bringing new ideas with evidence of impact into the school. The main aspects of that professional inquiry are shared here on this screen, but I would draw your attention to the fact that a professional inquiry project is designed to be shared, the last point here, to be shared within and beyond faculty, and thus facilitate collaboration and support workload, something we know in education is vitally important. So my title of my project became "What impact does the sequence and explicit teaching of the threshold concept of atomic bonding and chemical properties have on Year 10 student outcomes?" I chose to look at the teaching of threshold concepts in chemistry because I'd never considered really threshold concepts within my subject. It was something that was a bit alien to CNS staff in terms of just that term. We certainly understood what misconceptions were in our own subject areas, but I'll be honest, I wasn't really sure where this was going to head. But what I was conscious of, very conscious of, was that certain concepts in chemistry provided huge barriers for some students to make progress. And so the idea of looking at what that threshold concept might be in chemistry and something to really focus on really interested me. So what is a threshold concept? Well, in its nutshell, if you like, they are the parts of the course that, until they are understood, prevent student progression. And as experts, we find those difficult to identify because we've actually rarely struggled, especially at the school level of understanding. We've rarely struggled to grasp that concept within our subjects, hence we've become experts of them. So they're difficult to identify to start with because where do students get stuck, which means they can't progress? And then, as complex concepts, which they often are, they rely on the conceptual, the epistemological, and the ontological experiences of our learning. The structure of learning to be able to transition between ontological to conceptual and theoretical understanding is really crucial to this research and this project. In terms of the background then of why I chose this particular project, I was so aware of the ongoing time-spanning statement, "I'm no good at science." Parents and grandparents will say it now at open evenings when they come in and find you're a chemist. So it felt right to look at where and why students switch off as they move into Key Stage 4. Could there be a way of resequencing the lessons or teaching in a different way that would help student confidence and motivation in science? And one of the first aspects then, in terms of our professional inquiry, is the research. And the school shared lots of different bits of research related to threshold concepts, but these four really resonated with me. And as I know many of you know, Nikki, who does an awful lot of work in terms of research and has been sharing all of the research ed information on Twitter. Her work on mimicry, not mastery, and the threshold concepts and cognition in science, again, really resonated with me and underpin a lot of what I've done in my project. The work from Vincent, the threshold concepts in chemistry, made me really challenge what we were doing in terms of sequencing and really provoked my thought processes in terms of, is it the sequence of lessons as well as just the concepts that we are teaching as well that has the biggest impact. What I found really interesting and what helped me to think about what we were learning, what part of that was preventing that threshold breakthrough, what was stopping students progress. The most interesting bits that I found were where Nikki focuses on the idea of macro to micro level teaching. And although it sounds cliche, this was a real light bulb moment for me. I had taught bonding from the atomic conceptual level to properties and the macro level in that order for 16 years. This is the scheme that is shared in all Key Stage 4 specifications, in textbooks. It's just the way it was done. And Nikki really challenged that idea and is quite vocal in promoting a macro to micro approach. And of course, my main aim was to look at why students switch off and consider why chemistry became inaccessible. So when I considered Nikki's ideas and where she's saying, students, are they understanding the properties of ionically bonded substances? It was clear to me that they were thinking of just the love relationship between one ion, one positive ion, and one negative ion. And they weren't considering the salt that they knew in the kitchen. They weren't considering what the conceptual level that they were learning about in the classroom and how that was linking to those physical properties that they see in their everyday life. I also was thinking when they couldn't link the ideas of intermolecular forces of carbon dioxide, I think it was because they couldn't imagine seeing more than one molecule that they had just spent lots of lessons drawing in their book. It was clear I needed to consider training their brains actually to visualize these molecules in terms of their already existing knowledge of carbon dioxide that was all around them, rather than build from atomic diagrams first. And so I just simply changed the sequence of my teaching. I won't talk you through each of these 10 lessons, but you can see how the macro level and the substance properties are investigated first. So in red there, you can see it's very much macro focused to start with, and micro concepts come in slightly later on. We then, after we've taught the macro level, we then encourage students to predict, well, what might that look like on a scale that's invisible to you, the micro level. And once the macro and the micro understanding was grounded, we started then to introduce topics like the halogens and noble gases and allotropes to unpick the misconceptions that may still exist between the macro and the micro links. And really importantly there, in lesson 1, you will see that the macro level teaching was simply looking at properties of substances, salt versus sugar, things that they already knew about in their own world, and reviewing those properties enabled them to understand the properties of ionic and covalent substances. Through my research, I also came across these ways of triangulating macro and micro and see if students were making the links that they should be making. In both instances, the students appeared confident in linking diagrams to concepts and vice versa. On the left, the work shared by Ed Thorpe and then retweeted by Nikki shares one worksheet just looking at ionic bonding, but just looking at the macroscopic level, the theoretical level, and what I really liked was that communicative, the symbolic aspect of chemistry. And actually, if you understood where they've gone wrong in any one of those 3 areas, you'll know which part of the topic they had missed. The one on the right-hand side from the Royal Society of Chemistry is just really well, cleverly designed true or false questions, whereby by changing one small word or just rephrasing the sentence in a slightly different way, the answer would be affected true or false. But it unpicked the atomic level and the giant lattice level of teaching ionic bonding just through sodium chloride. And ultimately, we need to know, does it work? We have to look at the impact of what we have been doing. And with my data head-on, I wanted to use our short assessments followed by our more formal mid-year assessments. And you can see here that in terms of year 1, the year 10 threshold group that I have been working with the macro to micro teaching, averaged 64%. Now that's only 6 students, but compared to the whole year group, which did not have the macro to micro teaching, they only averaged 48%. And this is just for combined science, I should point out, not triple science. In year 2, however, when we then upscaled this and we introduced the macro to micro teaching to the whole of year 10, and we published new resources and a new scheme of learning, we see that the whole of the year 10 cohort moved up from 48% to 65%. In terms of the more formal mid-year exam, we see that the threshold group that I was working with, actually there is no big difference between the covalent substances questions, 50%, 56%. But when we look at the ionic substances more on the right-hand side there, we see that that threshold group that I've been working with averaged 56% compared to the whole of the year 10 cohort who averaged 32%. Unfortunately, with lockdown and lots of papers being locked away in our deeply cleaned school, we're unable to look at the question level analysis between these topics, but what we have got are the overall scores of the mid-year exams. And we can see here that in 2019, the whole year 10 cohort averaged 3.1 as a grade, compared to this year where they've averaged 3.6, and bonding features very highly in that assessment. So to conclude, there are many positives here, but with my data hat on, I do have to urge some caution in terms of looking at this data. There are huge issues with the cohort size that I used in year 1 and whether any of these gaps really are statistically significant. And with COVID cancelling the GCSE exams, unfortunately, I'm unable to see what that looks like in terms of a whole exam type scenario. But what I will say is that actually it did enable me to unpick a lot more misconceptions. It was easier for me to be specific in the use of language when teaching down from macro to micro. And actually, of the data that we were looking at, it did tend to show a positive impact. It certainly, as an experienced teacher, I can vouch for the increased level of understanding and confidence that I've seen in my students, and it's something that we will keep at CNS moving forward. So where to next? I would like to consider moving the same approach down to Key Stage 3. I think we teach properties at Key Stage 3 very well, but I also think that we need to be thinking about ahead of every topic, we think about the macro level, that real life understanding in more detail than we do. And also, the most important, in all lessons, I think we should take the opportunity to establish that micro level grounding before we start to link to conceptual and theoretical explanations. Thank you very much for taking time to listen to what for me has been a really enjoyable and eye-opening 2 years and piece of research. If you are interested or you would like a copy of that paper, there's a full paper written on it, and I'm very happy to share that with you. And it does contain the full new and improved scheme of learning with resources as well. So please feel free to drop me an email. Thank you. Bye-bye.